Hello again, dear students. We are in Ferkhwa's website at your service to explain physics curriculum, grade 12. My name is Masoud. We are going to complete our solutions of the questions of chapter review. So far, we solved and answered 14 questions. Right now, we are going to solve question number 15. Let's say we have a problem here. A small pebble breaks loose from the treads of a tire with a radius of 32 centimeters. So a pebble, let's say, breaks loose. A pebble, let's say, ejects from a treads of a tire with a radius of this one. So this is the radius of a tire. This is R. You have to convert it to meter by dividing by 100, right? Either you divide it by 100 or you multiply 32 by 10 to the power negative 2 meter. That's it. Whether you use this form, decimal fraction, or scientific notation, as you like, no problem. It says if the pebble's tangential speed, what's this? This is Vt. Tangential speed, 49 meters per second. What's the tire's angular speed? What do we look for? We look for omega, right? So omega is equal to Vt over R. Vt, 49 divided by 0.32, 153 rad per second. That's it. Question 16. A building superintendent towards a set of keys, let's say circles, a set of keys in a circle at the end of a court. At the end of a court, if the keys have a centripetal acceleration of this number. What's this centripetal acceleration? And the court has a length. And the court has a length of this value. This is the length of a court. The length of a court becomes radius of a circular track, and this is AC. What's the tangential speed of the keys? We look for 80 here, right? Tangential speed of the key. Tangential speed, actually Vt, not 80. I made a mistake. Let me correct my mistake. Actually, we look for Vt, right? So AC is given, R is given. We look for Vt. Vt is equal to radical R AC. And this is the rearranging of this rule. AC is equal to Vt squared over R, right? You look for Vt, that's why R becomes radical RAC. Vt becomes radical RAC. Vt is equal to R is equal to this value of 0.34 multiplied by 145. We don't have any conversion because the units are unified, and the answer will be 7 meters per second. That's it. Question 17. Let me solve question 17 for you. Let me read the question. It says, imagine that you attach a heavy object to one end of a spring, and then while holding the spring's other end, whirl the spring and object in a horizontal circle. Does the spring stretch or not? Right? I give you a spring. Think about the situation. Whenever you hang the object to the end of the spring, like this, for example, there's a spring. Let me show it to you, right? And you, let's say, attach it to an object, and after that you twirl it, you whirl it, or you circle it. Does the spring stretch or not? Does it elongate or not? Of course, it elongates, right? It stretches. This is the first part. We say yes, this is the first part. It says, discuss your answer in terms of the force that maintains circular motion. So which force, let's say, maintains circular motion here? Which force does the spring have? Think about it. Of course, it has a, let's say, force of, we can say, tension, or it's not a tension, elastic force. Has elastic force. So the first part, yes, this is the answer of teacher's book. Explain your, let's say, your answer. And before I read the answer for you, I'm gonna, let's say, I want you to focus on this part. Does the stretching, let's say, limited or unlimited? And which factor or which force, let's say, controls the situation? Which force, let's say, makes the radius of the spring or radius of a circular track constant? Think about this force. Actually, the force has to do with the spring itself. The spring has this force. Let me read the answer for you. It says, yes, the object moves in a spiral path, right? And because of inertia, of the mass, right? The object's distance increases outward until the spring force, elastic, actually it has an elastic force, negative kx is great enough to what? To keep the object at a constant radius. So what force keeps the, let's say, keeps the radius of a circular track constant? Of course, the force within the spring, and this force is called elastic force. Actually controls the, I can say it, elastic force provides the constant radius for a circular track. Let's move on to question number 18. Right, let me read it for you. Question number 18. Why does the water remain in pail? Let's say that is well in a vertical path. Why does the water, let's say, remain in a pail, and the pail is upside down? Sometimes you, if you, let's say, try this situation, you can get, actually you can get this case. It says, as shown in the figure. I can say the, let's say, answer in other words. Why doesn't water, let's say, fall? Why doesn't water pour when the pail, let's say, is upside down? When the pail is inverted, actually, especially at the top of the, let's say, like this, at the top of the path, why doesn't water actually pour? Right? Which factor holds the water in a pail or in a bucket? Let's read the answer. It says the water remains in the pail even when the pail is upside down. Right? Like this case. Let's say, drew it for you. Because the water tends to what? Tends to move in a straight line due to what? Due to inertia. So simultaneously, there are two phenomena. I can say inertia of the water tends to move the water in a straight line. Right. That's the first one. Does the water and the pail have the same acceleration? Simultaneously, actually, I told you there are two phenomena. The first phenomena, inertia. Inertia tries to what? Tries to move the water in a straight line, and gravity, Fg, or weight of the water, tends to pour the water downward. So by means of these actions, I can say pail and water themselves, pail and water together, have the same, let's say, acceleration. I can say pail and water, they are in free fall. Pail and water in free fall. They have the same, let's say, acceleration due to gravity. That's why it doesn't pour. Right? This is the case. This is the explanation and interpretation of this question. Question number 19. It's a question of national exam. Let me read it for you. Explain the difference between centripetal acceleration, AC, right? And what? And angular acceleration means alpha, right? We want to distinguish between AC and alpha. I prepared it in a table. Let's say I summarized it into 2 points. The first one, for centripetal acceleration, or AC, the time rate of the variation of the direction of velocity when it moves on a circular path. Just write the definition of centripetal acceleration. About the angular acceleration, write the definition as well. The time rate of change of angular speed. The second, let's say, difference, just write the unit of either. Unit of centripetal acceleration is meter per second square. What do you say about the unit of angular acceleration, or alpha? It's rad per second square. And this is one of the questions of national exam. Question 20. Let me read the question 20. It says, comment on this statement. There is no gravity in outer space. Do you believe that there is no gravity in this space? Of course, it's wrong. A lot of people believe that there's no gravity in this space, but this is an irrelevant speech. It's not true. Let's discuss it and interpret it. This is the answer of teacher's book. It says, gravitational force between distant object is negligible. Actually, in outer space, because let's say stars and planets are, let's say, away from one another. They are at, let's say, at distance. There's a, let's say, huge distance between the objects. Let me give you an example. The nearest, let's say, to stars, right? Think about the stars. Our star, sun, is our size sun, right? You have to travel 3, let's say, light years or 4 light years. I'm not sure right now, but for example, say 3 light years, right? You have to travel 3 light years to reach the second star. So nearest, the second nearest star from Earth, from Sun, is far from the Sun by 3 light years. That's why objects are very far away from one another. You cannot say gravity does not exist. Gravity exists, but it's negligible. It approaches to 0, but in some positions. But actually, sky is not absolute empty. It's not just stars. Actually, it consists planets. It consists moon. Even in some cases, gravity becomes 8, and is a huge number. Yeah? We cannot say gravity is 0. I told you, gravity changes from one position to the other in outer space, but you cannot say gravity is equal to 0. Gravity never be 0, right? Thank you guys for watching this video. I'm gonna finish the lecture here, the lesson here. And I want you to follow our videos, our next videos, and bye for now.